Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns integration by parts. This guide defines the formula for integration by parts. It gives advice about when to use the integration by parts formula and describes methods to help you use it effectively. Introduction. Integration and differentiation are the two parts of calculus, and whilst there are well-defined rules to differentiate almost all functions, being able to integrate any given function is not so easy and requires experience, as there are many techniques. Although integrating basic functions is a fundamental skill, study guide, integrating basic functions, often you will find that the function you have been given to integrate is more complicated. One common method of integrating more complicated functions of a certain type is integration by parts. As with differentiating, it is crucial when integrating to be able to identify the form of the function you have to integrate. Once you know the form of the function, you can make a good decision about the rule you wish to employ. You can use the method of integration by parts to integrate many complicated functions which are made by multiplying together more basic functions. You can learn more about these types of functions in the study guides, More Complicated Functions and the Product Rule. If you are unfamiliar with the language used to describe integration and differentiation, you may find it useful to read the study guides What is Differentiation, What is Integration, and Definite Integrals before carrying on with this guide. The integration by parts formula for indefinite integrals is given by the integral of u multiplied by dv by dx with respect to x equals u times v minus the integral of v multiplied by du by dx dx. On the left hand side of the formula you have an integrand which may look strange because it is made by the product of a function u and the derivative of a function v, dv by dx. Both u and v are functions of x. You use the method of integration by parts to integrate more complicated functions which are the product of two basic functions. However, unlike the product rule from which integration by parts is derived, the substitutions that you make are not u and v, but u and dv by dx. Take the following integral. The integral of 2x multiplied by cos x with respect to x. As the integrand, 2x cos x, is a product of the two basic functions, 2x and cos x, it is appropriate to try integration by parts. You can use the integration by parts formula by first assigning u to one of these functions in the integrand and dv by dx to the other. Usually, if a power function is part of the integrand, it is good practice to let it equal u. The choice of dv by dx is the other function by default. The reason for this is that you differentiate u and so reduce the power of x by 1. This leads to a simpler integral on the right hand side of the integration by parts formula. A table listing common functions and good choices of u and dv by dx is found at the end of this guide. In this example, which contains a power function, it is sensible to make u equal 2x, which means that dv by dx equals cos x. Next, to solve the integral, you need to find v and du by dx and substitute them, along with u, into the right hand side of the integration by parts formula. Remember that you have to differentiate u to find du by dx, integrate dv by dx to find v. Integration by parts is so named because you differentiate the one part of the integrand, u, and integrate the other part, dv by dx. Therefore, it is important that you know how to differentiate and integrate basic functions to use integration by parts effectively. See study guides, Differentiating Basic Functions and Integrating Basic Functions. Here, du by dx equals 2 and v equals sin x. Substitute these results along with u equals 2x into the right hand side of the integration by parts formula to give uv equals 2x sin x and the integral of v multiplied by du by dx with respect to x equals the integral of 2 multiplied by sine x dx. The right hand side of the rule gives the answer to the integral. It is also unusual as it contains two terms, the second of which is another integral that you must perform by an appropriate method in order to find the answer. If you assign u and dv by dx to the correct functions in the left hand side of the formula, then the integration on the right hand side should be either as simple as or simpler than the original problem. If you do not, the integration will be more difficult than the original problem, and you should swap your substitutions around. Here, the integral of 2 sine x dx is simpler than the original integral of 2x cos x dx, and so the choice of u equals 2x and dv by dx equals cos x is good. If you are unsure whether to use integration by parts or another integration method, the most important question to ask yourself is, am I integrating a product function? Practicing problems is an excellent way of gaining experience of integration methods, as it helps you make good decisions about which methods to use for certain types of problems. When you are answering longer, more complicated problems, you may find it useful to divide your page vertically into an answer space, where your answer will be written, and an exploring space, where you can do any working and thinking which informs your answer. Here we have divided our page into answer space and exploring space. The question is to integrate 2x cos x with respect to x. Let u equal 2x as it is a power function, so dv by dx equals cos x. Use integration by parts. The integral of u multiplied by dv by dx with respect to x equals u times v minus the integral of v multiplied by du by dx with respect to x. For the formula you need u, du by dx and v. Differentiating u with respect to x gives du by dx equals 2, and v is given by the integral of cos x with respect to x, which equals sine x plus c. Now inserting all these into the integration by parts formula. U is 2x, dv by dx is cos x. Again, u is 2x, and v is sine x. Finally, du by dx equals 2. As you can see, arrows can help you with the substitution. The indefinite integral on the right hand side is the integral of sine x multiplied by 2 with respect to x, which can be rewritten as the integral of 2 sine x, which is a basic integral, and so equals minus 2 cos x plus c. So the integral of 2x cos x with respect to x equals 2x multiplied by sine x from the u times v part of integration by parts minus 2 cos x plus c, which comes from performing the integral part of integration by parts. Using brackets can help with the minus signs. Now open the brackets to find the answer. The integral of 2x cos x with respect to x equals 2x sine x plus 2 cos x plus c. Check you are correct by differentiating your answer using the product rule. This should give your original integrand. Calculating definite integrals using integration by parts. The study guide, Definite Integrals, describes how definite integrals can be used to find the areas on graphs. The integration by parts formula for definite integrals is analogous to the formula for indefinite integrals. So, between the limits x equals a and x equals b, the integral of u multiplied by dv by dx with respect to x between a and b equals u times v, evaluated between a and b, minus the integral of v multiplied by du by dx with respect to x, evaluated between a and b. Example: integrate 2x multiplied by e to the power 3x with respect to x between 1 and 4. Firstly, divide your page into answer space and exploring space. The question is to integrate 2x multiplied by e to the 3x with respect to x between 1 and 4. Let u equal 2x as it is a power function, So dv by dx equals e to the power 3x. Use integration by parts for definite integrals. The integral of u multiplied by dv by dx with respect to x between a and b equals u multiplied by v evaluated between a and b minus the integral of v multiplied by du by dx with respect to x evaluated between a and b. For the formula you need u, du by dx and v. Differentiating u with respect to x gives du by dx equals 2 and v equals the integral of e to the 3x with respect to x, which equals 1/3 of e to the 3x. Putting these results into the integration by parts formula gives u is 2x, dv by dx is e to the power 3x. So again, u is 2x, v is 1/3 e to the 3x, again v is 1/3 e to the 3x, and du by dx equals 2. The definite integral on the right hand side is the integral of 1/3 e to the 3x multiplied by 2 with respect to x evaluated between 1 and 4. This can be rewritten as the integral of 2/3 of e to the 3x with respect to x between 1 and 4, which is a basic integral. The answer is 2/9 of e to the 3x evaluated between 1 and 4. You can put this result back into integration by parts. So, evaluating at the limits, the integral between 1 and 4 of 2x multiplied by e to the 3x with respect to x is 8/3 of e to the 12, which is this piece of maths evaluated at x equals 4, minus 2/3 e cubed, which is this piece of maths evaluated at x equals 1, minus 2/9 e to the 12, which is this piece of maths evaluated at x equals 4, minus 2/9 e cubed, which is this piece of maths evaluated at x equals 1. If you're unsure, you can follow the method for working out definite integrals given in the study guide, Definite Integrals. Take care with minus signs, using brackets can help. This answer can be checked using the product rule. So, the integral between 1 and 4 of 2x e to the 3x with respect to x equals 22/9 e to the 12 minus 4/9 e cubed. Using integration by parts more than once. When integrals contain higher powers of x, you may need to use integration by parts more than once to obtain a solution. In general, if an integral contains x to the power n, then you will need to use the integration by parts n times. Example, what is the integral of x squared multiplied by sine x dx? Separate your page into answer space and exploring space. The question is, integrate x squared sine x with respect to x. U equals x squared as it is a power function, so dv by dx equals sine x. Use the integration by parts formula for indefinite integrals. The integral of u multiplied by dv by dx equals u multiplied by v minus the integral of v multiplied by du by dx with respect to x. For the formula you need u, du by dx and v. Differentiating u with respect to x gives du by dx equals 2x and v is the integral of sine x dx, which equals minus cos x plus c. Again, arrows can help with the substitution. U is x squared, dv by dx is sine x, again u is x squared, v is minus cos x, again v is minus cos x, and du by dx is 2x. Be careful with the minus signs. The integral of x squared sine x dx equals minus x squared cos x plus the integral of 2x multiplied by cos x dx. Notice that the integral that is part of the answer is less complex than the original problem. This is a good sign. In fact, this integral is the same as the one in the first example in this study guide. So, using the answer from that example, the integral of x squared sine x with respect to x equals minus x squared cos x plus the integral of 2x cos x with respect to x. This equals minus x squared cos x, which is the first part of the integral above, plus 2x sin x plus 2 cos x plus c, which is the answer to the integral of 2x cos x dx. You can check this by differentiation using the product rule. As you used integration by parts in the first example, you have had to use the method twice to find the answer, and the power of x in question was 2. Solving recurrent integrals using integration by parts. There are some types of problems, those which involve an exponential function multiplied by a trigonometric function, where using integration by parts will not generate a more simple integral in the answer, but instead will produce an integral of the same level of complexity as in the question. As neither of the parts of this product decrease in complexity when they are differentiated, using integration by parts on these problems has a circular nature. Solving these problems is an excellent example of elegance in mathematics, as the method regenerates the original integral, which allows a solution to be obtained by rearrangement. Example: determine I equals the integral of e to the power x multiplied by cos x dx. Divide your page into answer space and exploring space. You have to integrate e to the x cos x with respect to x. Let u equal e to the x and dv by dx equal cos x. Use the integration by parts indefinite formula. The integral of u multiplied by dv by dx equals u times v minus the integral of v multiplied by du by dx multiplied by dx. For the formula you need u, du by dx and v. Differentiating u with respect to x gives du by dx equals e to the x and v equals the integral of cos x with respect to x, which equals sin x plus c. You can use arrows to help with your substitution. So u is e to the x, dv by dx is cos x, again u is e to the x, v is sin x, again v is sin x, and du by dx is e to the x. Notice that the integral you have generated here is similar to the original question, with cos x replaced by sin x. Here, it seems sensible to perform this integration by parts as well. Separate your page into answer space and exploring space. Now you want to integrate e to the x multiplied by sin x with respect to x. Let u equal e to the x and dv by dx equal cos x. Use the integration by parts indefinite formula. The integral of u multiplied by dv by dx with respect to x equals u times v minus the integral of v multiplied by du by dx with respect to x. For the formula you need u, du by dx and v. Differentiating u with respect to x gives du by dx equals e to the x and v is the integral of sin x with respect to x, which equals minus cos x plus c. Substituting these into the integral gives the integral of e to the x sin x with respect to x equals minus e to the x cos x plus the integral of e to the x cos x with respect to x. Substituting this result into the first part of the answer gives the integral of e to the x cos x with respect to x equals e to the x multiplied by sin x plus e to the x multiplied by cos x minus the integral of e to the x multiplied by cos x with respect to x. You can see that both the left and right hand sides of this equation contain the original question, I, here. So, re-expressing the result in terms of I, you get I equals e to the x sin x plus e to the x cos x minus I. So after rearranging for I by adding I to both sides and then dividing by 2, you get I equals the integral of e to the x cos x with respect to x, which equals e to the x multiplied by sin x plus e to the x multiplied by cos x, all divided by 2, plus c. When to and when not to, use integration by parts. The following table gives some general product functions which can be integrated using integration by parts, and suggestions of what to use for u and dv by dx. So the general form, where a, b and n are constants, the integral of ax to the n multiplied by sine of bx. For u, choose ax to the n. For dv by dx, choose sine bx. For the integral of ax to the n multiplied by cos bx with respect to x. For u, choose ax to the n. For dv by dx, choose cos bx. For the integral of ax to the n multiplied by e to the bx with respect to x. For u, choose ax to the n. For dv by dx, choose e to the bx. For the integral of ax to the n multiplied by the logarithm of bx with respect to x. For u, choose the logarithm of bx. And for dv by dx, choose ax to the n. For the integral of the logarithm of x with respect to x. For u, choose logarithm of x. And for dv by dx, choose 1. Integration by parts is not always the easiest method to use, especially with trigonometric integrands. Take sine squared x, for example, which can be written as sine x multiplied by x. Integration by parts can be used, but it is much simpler to use trigonometric identities and integrate 1/2 minus 1/2 cos 2x instead. Further guidance and information. If you have any further questions about calculus, or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of calculus, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.